Oh, hi everyone. I guess we are live again. Thanks for making it and joining our Terramate Office Hours Volume 5, even with a little delay on a Thursday instead of our bi-weekly Wednesday. Anyways, big thank you to our community. And I'm also happy that Sören is with me. Hi, Sören. How are you? Where are you? And what are we going to talk about today?
Yeah, thanks, Selina. I'm doing good, doing good. I'm in California still. So I'm going back to our headquarters in Berlin by the end of this week, and yeah, doing good.
Great.
Spent the past couple of days in San Francisco and talking to the community there. And, yeah, really, it's a really good vibe over there always. Such, creative productivity in the air everywhere. Yeah, and other than that, it's been an interesting couple of days or weeks with the whole copyright theft allegations toward open tofu. Made a big buzz in the industry. Yeah, Selina, you followed it too. And was
Yes.
interesting to see. I think that the one problem that exists here is that for open tofu, for open tofu to innovate, there's always going to be some sort of overlap in the ideas with what Terraform is doing. That's also okay. So I think finally the end goal here is that OpenTofu will diverge from Terraform over time by providing better features and better functionality, specifically stuff that has been requested by the community for years. So there's lots of room to innovate here. But sometimes it just also means that, hey, we need to look at things that are similar, at least to some extent in Terraform. Yeah? So because of the licensing, because of the licensing difficulties, that means you can't just directly copy code, and I also don't think that this is the ambition. Instead, of course, the ambition is to implement this ourselves. And so what happened here in the past 2 weeks is that some functionality that exists in Terraform was also implemented in OpenTofu, and it led to wide allegations that OpenTofu basically just copy code here, which is not true, which is also, very clearly identifiable by looking at the source code and how this has been developed. And so OpenTofu just issued a statement on this, which I also shared in my LinkedIn profile this morning. Um, Let me quickly pull this up here. Um, and that sort of gives the big picture. So just look at this real quick. So they have this our response to HashiCorp cease and desist letter, where basically the core team that is working on this explains in detail what has happened and how we respond to that. And the bottom line here is for me, so I'm not super actively involved at the moment when it comes to the actual development. Yeah, I follow very closely. I'm in touch with the team, but I'm not contributing. So right now, this will change in the future. But I need to say it's really good to see how healthy and calm the team addresses such allegations and issues, and even more so the way that OpenTofu responds here by, not finger pointing directly, but by or not getting upset or so, and not starting a war essentially, but by leaning on facts is quite refreshing to see. So I think that was the most it created the most buzz in the industry in the past 2 weeks. There was also an article published on some internet newspaper that underlined the allegations here. And it's good to see that it's actually not true. By the end of the day, and I've said this a couple of days ago, I think we're all working on the same goal here. And there's space for Terraform, there's space for Open Tofu in the industry, and both do good work. So yeah, hopefully, I'm not here to advocate for one another solution. Even though I'm of course a strong fan of Open Tofu, as I am of Terraform, really. But by the end of the day, let's yeah see that we can work on a healthy ecosystem altogether, especially specifically when it comes to where the value is. And a lot of the value is in the actual providers and in the actual modules and the ecosystem built around Terraform and around OpenTofu, the tooling. There's great tooling out there, InfraCost, Checkoff, TFTech, Drivey, and whatnot. All right. Because you asked for the topic of today's office hour. 1 second. So today we'll be focusing on code generation in Terramate. And let me pull up my slides.
Yeah, as always, you can also ask your questions and we will answer them at the end of this session. So feel free to comment at every time. I will have a look.
Yes, awesome. Sorry, it took some time here. So again, thanks for dialing in. So code generation in Terramate, focus on today's topic. If you already use Terramate, you probably noticed that Terramate comes with many different things. One of the things that we're doing here, and I think we're doing really, really good, is the generation of HCL code, of Terraform code, and really all other code in Terraform stacks managed with Terramate, right? And there's a few use cases why you would want to do that. So for example, one thing is to keeping stacks dry, right? So to generate repeated files such as Terraform backend configuration, Terraform configuration itself, provider configuration, etc. Another use case here is templating. And templating basically means you can use the code generation to generate code with pre-configured templates, such as let's say S3 buckets or so. For basically enabling self-service, and we can do this by do this conditionally, basically saying like we automatically create this upon stack generation for specific stacks or so. We support HCL, JSON, YAML, and a few others. And what we can also do is we can basically bind specific data here, stack metadata, which we'll look at today, as well as variables, and in Terramate has different variables. So there's global values that can be reused and inherited through all my Terramate hierarchy, as well as locally available variables only that we call let's variables. So those are local variables. And we choose this name because locals already exist in Terraform, so we didn't want to conflict here. 1 second. All right. So if you get started with Terramate, can you see my screen, Selina?
Maybe you can make it a little bit bigger.
Okay. So if you get started in Terramate, first thing you probably do is installing the CLI. Yeah. But what many of you probably have not noticed yet, the CLI comes with the CLI tool that we all use and like, and most likely you use this for creating stacks, but then also for the code generation itself. But Terramate also distributes with a language server. And we call this Terramate ALS, so Terramate Language Server. And this can be natively integrated with your IDE. So with VS Code or Vim, we provide plugins here. By the way, we also have auto completion for the CLI. And the reason why we do that is because the way that Terramate differentiates from most of the other tooling in the market is that the code generation in Terramate is pretty sophisticated, and we build on top of HCL here. So let's look at an example on how we actually do this. Before this call, before this webinar, I basically created a new directory called code generation, and I created a repository in here. And now let me start up my VS Code, which you should be able to see now. So it's an empty repository, really. there's no files in here, and I already installed Terramate version 0.6, which is the latest version. I think next release is to become next week with also pretty interesting updates. So if we look here at the documentation, um, you can see in the core concepts, we have code generation as one of the main concepts here in Terramate, yeah. And what you can see is the code generation, the way that it works is by using this configuration blocks here. So in the config.tm.htl. As I mentioned in my slides, we have support for HCL code generation. This could be any kind of HCL, yeah, OpenTofu, Terraform, any other HCL configurations, Packer or whatnot, because we believe that HCL is the superior configuration language, yeah, compared to YAML also. Sorry. All right. I'm just sitting in a public place here. Let's look at this a little bit more, by basically trying this out. So what I want to do is here, I want to add the main.tm.htl. What is important to understand is that this configuration in Terramate is being merged, similarly to what we know from Terraform at build time. So it doesn't really matter how I name this file. It also doesn't matter across how many files I split up my configuration. And let's do one thing here. Let's use this example to basically generate a bunch of Terraform code here. So we'll come up with this generate HCL statement. Yeah. And you can see already what this expects here is a file name. So let's name this main.tf. Basically what the statement says is, hey, I want to generate a file, an HCL file, and I call this main.tf, and then with specific content. So now if I run Terramate generate, this won't do anything, right? Because the HCL code generation is meant, by default, is meant to generate code in stacks. So what I also want to do, I want to just create a stack. Let me do this. Terramate create stack. I'm just going to create one stack here in this project. And now you can see up on stack creation, with Terramate create new stack, we see that this stack directory gets created, based on this path here. We have a stack.tm.htl with the name and the description and an ID. Let's remove this once again and see what we can also do here. We can, of course, also create a stack and say, hey, this is a stack, a stack. We can give it a description. Awesome stack description. At some point, I will teach you how to do all of this, or show you how to do all of this, Selina.
Looking forward to this.
Yeah, learning some Terramate and Terraform. So again, I have the stack up now. I created it, and now what you can see is that I can programmatically pass all this configuration parameters here as attributes to the CLI. ID, and we discussed this many times before, is created upon stack creation for us automatically. And you can see the main.tf file here is empty. And this is because we haven't defined any content here. So now what we can say, oh, you know what? Actually, we want to have a resource in here. Now, this is just an AWS instance, just an example instance. So what this basically does is it says, hey, generate a file main.tf in all stacks, with the following content. If I run Terramate generate again, you can see that this main.tf file gets regenerated. And now it contains, now we have content in here. Okay, so what we also know is that we can add a condition here. Per default, the condition in the code generation is always true. We can set this to false. And now it says, hey, generate then a file main.tf, but don't do this in any stacks because the condition is false. If I run the generate command again here, what we can see is that this main.tf file gets removed. So the difference here is that we can basically conditionally create, update, and also delete files from our stacks. And we can do this by using language constructs and semantics that basically enable us to do this programmatically. And I mentioned a language server early on in this call. If I, for example, so what this means is I can use I can use the language service to basically validate my code generation statements inside of my IDE. And the IDE will give me feedback if I do something wrong here. Let's see if this is running. This is running. Okay. And perfect. Okay, so now what's next? We already discussed the concept of globals here, configuration. Yeah. Let's take a look at our documentation. So we have, if you look at the docs here, we have this section variables. And there's different types of variables in Terramate, in variable namespaces. So we have the Terramate namespace, which basically provides us with context about the stack. Let's take a look at this. So we can see that, we have project metadata and we have stack metadata here. So for example, with Terramate stack name, we can access the name of a specific stack upon code generation. So let's look at this. If we, for example, say, I think we can add here something like tags. Name, hello world, for now. If I regenerate this code, nothing happens because condition is set to false. So let's set this to true. So we actually generate code. If I regenerate the code here, we can see this main.tf file gets generated with the desired code. So now what I can do here, I can say, hey, you know what? The name of this specific instance via a tag should always equal to the name of a stack. So what I can do is I can say, pull this in from the Terramate namespace, use the stack name. Running this again, regenerating the code. And now you can see the data that we use in here up on build time equals the desired name of our stack. If I set this to bstack and I run the code generation again, we can see this gets updated to the bstack. Okay, so set this back and generate again, and we have our name back here to A, reverted to A. So this is how we can use Terramate data, stack metadata. And there's a lot of stuff that we can use in here. So we can use the Terramate version, a list of all stacks, things such as an absolute path to a stack, or relative path to a stack, base name. And then we have access to stacks metadata here, such as tags. And that's quite cool because we could, of course, say, you know what? Only generate code in all stacks that, let's say, stack, so Terramate stack tags that contain the tag AWS. So now, if I run this again, this will remove my main.tf file. But if I add this tag here, and I call this AWS. So, by the way, Terramate also has an FM format comment with Terramate FMT. Oh, I think this is tags, actually. Yes, okay, sorry for that. So, if we run the FMT format, the format command, it basically formats all my files. So now this says, hey, only generate this main.tf in all stacks or in stacks that contain a tag AWS. So now if I run the generate command again, stacks tag, let me see, there's an error. Terramate stack tags with lowercase. Interesting. The way that we support tags here is by using lowercase. So I forgot about that. Let's try this again. This should work. Here we go. So now, if the stack contains a tag, AWS, we generate this code. If we comment this out, it's gone. And so what I'm saying, what I'm trying to say here, let's regenerate this once again, is that in the code generation, we can basically use conditions. There's different types of conditions. We'll look into this a little bit later to generate a bunch of code. So we can use the stack metadata not only in the actual content of a generated file, but also in conditions on, hey, what is a stack that, or what are the characteristics of stacks that should have this specific code? All right, so let's look at the next thing here. We already talked about the different concepts of variables here. What we want to look at today too is global variables. And what we can see in the documentation is, hey, globals allow you to define data that can be reused across multiple stacks using hierarchical merge semantics. This ensures consistent, easy data sharing within your Terramate projects and is often used for code generation. Let's look at this. So to declare a global or a set of globals, I can use the globals block in Terramate. So it's used this. This basically says, hey, define a bunch of globals by using the global configuration block. So what I want to do now is I want to basically say, you know what? Let's call this name. And then, or let's call this environment and set this to def. So now to use this here, I basically say global environment. If I run this, if I regenerate this, you can see the texts are probably generated here. But how about if a global does not exist? This TM contains here, I haven't explained this, but what this actually does is, in Terramate, not only do we have globals, but we also have functions. And functions can be used in all Terramate expressions. And basically what we made available here is all functions available as of Terraform 1.5.6, which is the latest available, open source available Terraform version. We'll add more functions here and also custom functions over time. Also to Terramate will be extendable, so you can add your own functions as you bring. And I know that the team just added support for provider-supported namespace functions. So you will also be able to bring those as a new way of managing functions with providers in Terraform. You will also be able to bring those to Terramate. And so that we don't conflict with Terraform functions, because you can, use the Terraform code generation to generate Terraform functions that are only evaluated at runtime, not at build time, right? Terramate is build time, but Terraform a plan is runtime. We append those with TM underscore. That's why it's not contains, but TM contains. Okay, so let's do this. In order for me to say, hey, whenever this global environment is not set, I want to basically set this to a default value. And I want to set this to def. So if I comment it, or to prot, maybe to show the difference, prot. So if I comment out my global definition here, and I run the generate command, what you can see is that this will be set to prot instead of def. However, if I uncomment that, this will be set to def. So now let's do the following. Let's move this to another file. Let's call this config.tm.hcl. And let's do a little bit more. Let's go a little bit deeper into the details. So what next? I want to basically create another stack here. Terramate create vstack. So now we have two stacks that are managed in our in our project here. Yeah, you can see stack has the main.tf generated. bstack does not. And that's because we set this condition here, and we said, hey, only generate this code inside of stacks that contains this specific tag. So let's add this here. Could also be done via the CLI, by the way, programmatically upon creation. AWS. If you run the generate command again, you see this file is here, and it's set, the name of this instance is set to bstack, versus the other stack is where we set this to a stack. Because the name here differentiates. We haven't set a name of creation. It just uses per default the name of the stack that we pass, so the directory name of the stack that we pass here upon creation. And you can see this is why it's called bstack here. So now, how about globals? We already learned by looking at the documentation a minute ago that globals can basically be configured, inherited, and overwritten at any point in our hierarchy. So that means if I'm copying this global block and I add a configuration file here in, Terramate configuration file, could really be any name, in bstack, and I set this to staging here, then in theory, this should overwrite the value declared in here. So let's run Terramate generate again. And we can see that this worked. So what I'm saying is that we can use globals to override specific values too. Let's look at a more advanced use case of globals. Let's say we call this configuration. So now we created a global in a specific namespace. And this namespace is called configuration. And in this namespace, we have a global environment. For us to use this, we need to go in here and we need to say, hey, so configuration. So this is a global in the configuration dot environment is the attribute that we want to use. By the way, this can be nested as you go. Let's run Terramate generate again here. And you can see that for bstack, so this did not work. Let me see, configuration. Oh yeah, this worked. Okay, because we have, did this work? No, this did not work. Yeah, because we don't override it here. So for us to override this global here, we of course need to also update the block here. And what's interesting is that, of course, not can we override specific attributes here, but we can also to this object add another object. So we could say, maybe we call this config, and then we add another config here, and we say foo bar. So we can come up with nested objects here too and add them to this namespace. Here we override an attribute. Here we add something to the namespace. They get merged deeply. All right. So let's go back to this config.tm.html. We already learned that we can use programmatic conditions. And for example, you could also use regex here to basically do regular expressions on stacks to on stacks paths to only generate this for specific stacks in a specific directory issue. But there's also another way. Let's comment this out and let's look at the code generation in here. So what we learned is basically we can use a condition or we use a stack filter. So stack filter allow you to filter stacks where the code generation should be executed. This could be path-based. So let's do this. Let's just copy this block. I'll run the formatting command here real quick. And now let's say we want to generate only in stack bstack. So now the code generation in theory should only run in bstack. And as we can see, this works. So the code generated file is removed here from the stack. And it's added to bstack. So we can, of course, also add stack here. Now this should run in both stacks, which it does. So this is just another way of using easier conditions so it's an easier abstraction layer to filter for specific stacks that the code should be generated in. Let's move back to conditions. Okay, so what else? We learned that globals, that we defined here are inherited throughout the entire directory architecture. It means a global is available here, a global is available here. But for example, if we come up with a nested stack, say stacks, so stack, nested stack, this gives us a name, nested stack, and then we give this a description, some nested stack. And by the way, I think we should be able to give this to add a tag here. I'm not sure if we support this already or not. Let me see. So this creates a nested stack. Yeah. And it also adds the tag here programmatically, so this works. Never tried this actually. And then it generates the code. But what we can see is the globals are also available in this nested stack. So they're basically inherited throughout the entire directory tree or project hierarchy. So, but how about if we want to use values computed for the code generation that should not be available to our stacks, but just inside this specific code generation statement? For this, we support the let's variable, what I already mentioned. And let's is basically, so what let's basically does is context-based variables that can be used to compute local blocks available in the current code generation block only to not pollute the global namespace. So let's look at how that would look like. With the let statement, we basically say, hey, declare some variables that are only available to this specific code generation statement. So now what we can say is, you know what, name should be Terramate stack name. And now I could say let name. This is how I access this variable in the code generation statement. So if I run the generate command, now nothing should change. That's what's happening. If I want to use functions in here, I can use tm upper. So this is let's look into this, string functions, tm upper, converts all case letters in the given string to uppercase. So let's look at this. By the way, if you want to play around with this, we have a playground here too, which basically allows you to run Terraform configuration inside the browser without ever installing the CLI. So if I go back to my project here, now that I use tm upper, can basically run a generate command again, and we can see now the name here is uppercase. So that's a way of using and declaring locally available data that is only going to be available within this specific scope. And it's quite helpful if you want to do computation on specific data that you need in the code generation, but you don't need this to be available through globals also. So we can, of course, also have multiple generate HCL files. Oh, the autocomplete here sucks. Inside of the same configuration file. So of course I could say here's another config. And let's say we just created locals here, Terraform locals. So now if I run generate again, this creates the config.tf in each specific stack. And we can use this by, to also create data such as Terraform variable configuration and whatnot. However, if I define data in here, this will only be available to the specific HCL statement. So if I want to reuse data among multiple generate HCL statements, we would need to use globals for that. And Of course, we can also, add all kinds of data to globals. We can also too, that's quite interesting, use Terramate data in here. So we can use can say Terramate stack dot name as the environment, which doesn't really make any sense. In the future, we will add native support for environments to Terramate stacks to basically make it easier for you to handle specific use cases such as Terraform workspaces. That's already possible with Terramate, but it doesn't feel like it's the best natural flow possible. So we want to add multiple environments, layers to Terramate stacks to basically allow you to use multiple workspaces very, very easy, and also to send this data to Terramate Cloud, which we don't touch today. Today is entirely focused on the code generation. Yeah. So the one thing that we need to understand here is generate HCL per default is meant to generate code inside of stacks. We cannot generate code outside of stacks as of today because of different contexts here. And there's also no real use case for it. But we've seen some requests in the community that were asking for this. So I'm investigating, what could be the use case to actually do this. If you look at so let's remove this here. If you look at the use case of globals, I mean, this is very typical here, the instance type. So here I would say something like, hey, TM try, let's say global configuration instance type, and I would just default set this to T2 micro. Whereas let's say, hey, in stack and all nested stacks, we want to have this set to T2 micro automatically. But in B stack, I actually want to send this to T2 small or so. So if I run generate again, now this will generate those files for me. And you can see here it has the small, here it used the T2 small, here it used the T2 micro. And for example, here I could even overwrite this again, and I could say, okay, add another configuration in here. Let's use this in here. So this is yet another layer of stack, and set this to T2 medium or so. So if I run generate again, this updates the specific code for my stack in here too. Yeah. So that's a little bit how we think about code generation in Terramate. So to summarize, what we have learned today is we learned that the code generation in Terramate is basically driven by so it's language parsing and compilation for HCL and files such as JSON, YAML, etc. that is built into Terramate. We define code generation statements and what code to generate really by using this generate HCL statements here and giving it a file name. We can add conditions in different ways to where and under what circumstances do we want to generate code, such as a condition or a stack filter, which per default always is true for all stacks. We learned how to declare globally global data with language constructs global in Terramate. It's globally available, inherited, extendable, and overridable throughout our project directory tree. It's too early. We have the let statement here, which allows us to declare locally available data only. And we also learned how to basically bind this data to specific code generation statements, how to use this with Terramate functions, etc. It gives us a really nice way of generating code conditionally. And the one thing that we didn't mention yet here is, of course, the outcome is always native Terraform code. So this integrates with all your existing tooling. You can integrate this with, you can use this code for static code analysis with TFLint, with Checkov, all other tooling that you really use in order to then get feedback on the generated code. Yeah. I'm writing a blog post at the moment on how to integrate code generation with Renovate dependency management tooling too. So if you declare module versions or so, it's a commonly known use case, for example, is to say, hey, not only do I want to create a resource here, but maybe let's look at AWS, Terraform module, VPC. Das ist Anton's Bebankos. Sorry, Anton, if you're listening, for the name here, Anton's module here. that we can just use. So let's pull this in. So now let's run the format command here. That's a great thing about code generation. We can mix all kinds of things here. We can use resources, we can use modules and interact with those. And now if we want to use a version here, we can of course either hard code this, or we can say, hey, tm try, and then let's say global modules VPC version defaults to 2.66. So it's running the code generation. This will update the file everywhere here. So now you can see, oh, now we also have this module code here and defaults to version 2.66. But if I want to use a different version in this specific stack, I can say, hey, globals. So what was the namespace that I think modules, let me see. The namespace was global modules VPC version. Modules VPC version. And this is then, oh, sorry, nonsense. So, and we set this to 3.0 or so. So now if we run generate again, it only updates the code for the module call. Here we have it, version 3, versus in all our stacks, it will still be version 2.6. So it's a nice way of programmatically managing module versions. You can use this for providers, etc. too. That's it as of today. Little hands-on code. Let's look at some questions if we have any.
Yes, there's some from our LinkedIn community.
Mhm.
It's actually a little bit of text, so maybe you want to read it by yourself, or should I read it out loud?
Well, you can read it aloud. I don't have LinkedIn open. That would be nice.
Okay,
Thanks.
let's say we have 4 resources in a single stack and want to use a global env variable for 3 resources and have an env variable with different value for the 4
Variable.
resources.
Variable, you
Variable,
mean. Variable.
variable,
Variable.
variable, yeah. Um, if I am not wrong, that needs to be done using context variables. But will global env variable still override the value of my local resource variable?
Yes. So the globals do not over. So what is asking for here is let me say this. Let me look at this. So the question is, if you want to use and override a specific variable, so global, let's align on the name global here. In stacks, you would use globals for this, right? So for example, how we define those. However, if you if you use configuration in Let's, this is a different namespace here. This is in a Let's namespace. So we can, of course, also generate a global here. By the way, globals, due to the nature that they're globally available, are defined outside of those statements. So I could say, hey, globals, and let's say name, foo. I cannot overwrite this in a let's statement because let's is a different namespace and it's only available to this specific code generation blocks versus globals is in the global namespace and it's available globally for all specific environments. However, I can use this in let's. So I can say, hey, okay, so maybe we want to use. So let's say maybe we want to use something like this. We want to say, hey, tm upper tm try. So, and then we say, hey, if the global name is here, use this. If it's not here, use the stack name. Yeah? And then you can see this updates to foo because I just added this wherever, somewhere. Ah, yeah, here. If I remove this, so what I'm saying is that it doesn't affect the name attribute defined in globals does not affect the name attribute defined in stack in Let's because it's a different namespace, but you can use globals in Let's and you can also reuse Let's in different Let's statements, just not the other way around because globals are not aware of Let's. Let's is let variables, so local variables are just available within the specific and generate HCL block. Hope that makes sense. So another question.
That's it from my side for
Yeah.
now.
So, well, then let me look at YouTube real quick. Oh, yeah. So that's an interesting question. Can I use for and for each in code generation? And the answer is yes, you can. So we can look at this real quick to maybe close. Let me share my screen again. So, okay, 1 second. So we have the TM dynamic block um, in Terramate, yeah. And what this basically does is it helps you to iterate over a set of given values defined in globals, onlet statements, and to then dynamically create content. So let's look at how this could basically look like. So what we could do is let's just remove all of this for now. And I'm gonna run generate now. Our stacks are empty. Just gonna remove all of this. And so we have one stack and the config in here to start from scratch. So what I want to do is I want to say, hey, globals, yeah, and basically, let's say we create a list of values here. Name is who or Alice and Bob. So, and now what we can see is like, okay, so we can use this to generate code with dynamic generation. So generate HCL main.tf content, and then we take this TM dynamic block, and let me show you how this works. Actually, this example is not super good in the docs. We should probably do this a little bit better in the future. Yes, I'm aware of this. So equals the signs. There's some, let me see real quick. Where is the mistake in here? Content. Oh yeah, I see. Okay, it's in here. This is what the arrow was saying. So now what we can say is iterate over so create a block, call this null resource. Yeah. And we can set the label here, or we can say set the label using the values, I believe. So let's say we do it like this. Value. Let me see if that works. Generate. So yes. So this creates, but of course this is wrong configuration. So what we want to say is resource, null resource, and then it would dynamically create those based on values available. And I can, of course, also use these values inside here if I want to create some sort of content inside of this null resources. Yeah. All right. Hope that helps. Any more questions on LinkedIn?
No, nothing from my side.
Okay, awesome. Well, thanks so much, guys, for tuning in. It was cool. Hope we could show you a little bit about the code generation in Terramate and how this works with different variables. Yeah, wishing all of you a great day, and feel free, as always, to join our Discord community at terramate.io/Discord. If there's any questions, you can always reach us in there. We're pretty fast replying to you usually. And other than that, we wish all of you a great and successful day and a great weekend ahead tomorrow. And then we talk in 2 weeks. In any case, there's also a webinar of ours next week, how to build taco-style automation platforms on GitHub Actions. So that's going to be cool. We'll share the link on LinkedIn later too, and in our community. Feel free to tune in, and wishing all of you a good day. Thanks, Selina, for handling this.
Thank you, Sören, and thanks to the community. Bye bye.